Hi, everybody. As I said, I'm Anthony Minessale, and with me here I have William King and Brian West. They're two members of our open source software team. And we're going to talk with them a little later. And we also have Ken Rice on the video screen here, who is a remote member of our team, who's running a WebRTC video conference using one of the features in Freeswitch. So he's just going to lurk there in the background till the end and talk to you guys a little bit. Okay, just going to go over quickly what is Freeswitch. In a nutshell, I tried to just be as generic as possible. It's software designed to run the most popular operating systems, designed to abstract, interconnect telephony, and other multimedia communication protocols. So basically, it's a C software application that can run on Windows and Mac and lots of Unix flavors. It'll accept various connections over things like SIP and whatnot and interconnect them. H323 and any other protocol that you could make a pluggable module for. It's a platform in which multimedia applications can be built, and that's through using loadable modules. It's very similar to Apache, how it would be for a web server, where you can get different mods for different behaviors. There's a whole bunch of ones that we publish, and you can also create your own if you know how to program in C. And we have some modules that gateway the functionality into simpler formats like HTTP requests and scripting languages and whatnot. And Freeswitch is an open source project that's been around. We're going into our 12th year. It's been kind of a long road that we've gone down through different era, because when we started this project, things were a lot different than they are now. But we have a really big community across the world, and we get contributions in the form of code and feedback from them. So I'm going to give a little overview of what Freeswitch was like when we first started 10 years ago in 2006. The primary focus was interconnecting ITSPs. There was a lot of use for that. We had this was an era where the telecom was breaking down, and we had lots of companies trying to sell SIP service, do-it-yourself ISPs, where they would get TDM hardware and put it in a rack somewhere and then offer SIP accounts to various other providers. And this is really the boom of that, and a lot of people were looking to Freeswitch to solve the problem of the aggregation of all the traffic for those kinds of services. And this is around the time when Level 3 was starting to build their services, but they were not as far-reaching as they are now. So you had a lot of people in between those wholesale providers. So they're either making their own SIP interconnects off of TDM, or eventually grew to resell other ones that cropped up. Back in that era, we were just implementing some stuff where the IETF was trying to work on adding chat features to SIP, and XMPP was trying to add audio features to Jabber. And at that time, that's interesting times for us. That's when Google first started working with Jingle, and they were making it popular at the time. And we had the Google Talk application that some of you may remember from back then. So at the time, we invented a module called Mod Dingling, which was our version of a Jingle module. Though at the time, Google chose to put a lot of work into the spec of Jingle. They really only implemented a completely different thing that we sort of had to figure out the hard way by trial and error. So our module for Jingle was compatible with the Google Talk because it was the most popular client, but really in reality there's a spec lingering in the background. This is spoiler alert, it's the beginning of what a WebRTC became. So I'm going to zoom through a couple slides. They're just going to cover like the last many years between then and now. So Google created the Google Voice, and they made it compatible with that same kind of Google brand of Jingle that they had. So at that time, they started to evolve to not only a desktop client for PC, but they had an application for HTML5 that was also using Google Talk built into it, and they had the Google Voice stuff. So along the way, they changed things a little bit, and we just kept rolling along with it. One day, someone would report a bug, we'd realize that they completely changed all their behaviors, and we would just write a new version of our software and release it. We went on doing that for a pretty long time. And we got the idea of adding video to Freeswitch, but at the time, there wasn't a real big surge of video. Some SIP phones could do it, but not really. And there were a few cases where it was kind of interesting. So we implemented video in a pass-through format where our audio was extensive as far as codecs all along. We've been able to do like different rates and codec formats. But for video, we basically just did pass-through because there wasn't a huge, like, it was kind of nice to have, but there just wasn't that many use cases for it. So it was hard to find the time to put the focus into it. And then we did have some people that were still using our mod dingling for Google Voice, but really it was starting to wind down. And the module actually still works today, but there's barely anything to do to use it for. But some have found use for it for SMS gateway, because if you have an SMS provider who uses XMPP, you can log into that. And Freeswitch has a lot of SMS functionality that you can bring your text messages in, as well as a bunch of other ways that have come up since then. But that's still a choice for some providers. And this is around 2012, Google's really evangelizing WebRTC, and kind of you seeing the end of the road for the Jingle stuff and for their support of it and the XMPP related stuff that they're working on. Along that time, we still focused on SIP because that's usually the one that gets the most attention over the years. No matter what we were doing, we have lots of different functionality and protocol interface, but everyone was still worrying about SIP because it was either using lots of SIP phones to build some kind of a PBX type application, or it was still the same aggregation of traffic thing that we did in the beginning. That's really never died down at all. There's still a large amount of our user base that are interested in using it for that. So in 2013, we decided that we're going to implement WebRTC because it seemed like the right time. We've been hearing about it, but we weren't really sure when we could find the time. But the interest was hitting. We kind of measured the air and decided that it was time to work on it. It gave it a little bit of a head start. Had a year to kind of materialize. So what did we think WebRTC was back then? We thought, it was a web browser speaking RTP. And it uses SVP just like SIP, so it'll be really easy and compatible with all the phones that I have. And all we need is probably just a new module, some slight modifications, but everything's going to be the same because it's using all these standards that have been around forever. And then, what was it in reality? Well, it's Jingle. We realized it. It was the exact same stuff that they were using before, only they took the signaling away. And so at least we had a familiarity with it, but it was kind of like this bane of our existence over the years because we would always have to keep up with the weird little changes that were going on. And it was kind of like there'd be new updates to the spec, and you'd have a whole group of people who would implement that spec right away, and they could talk to each other with it, but then we couldn't because we were using the one that works with Google stuff still. And most of our people that use Jingle for anything were to talk to Google Voice, so that was kind of frustrating for us, but that's like a day in the life of a developer, so it didn't stop us or anything. And it did use SDP, but there were so many new things that were being used that it really was clear it was never going to be compatible with anything that ever existed before this that uses an SDSP. And we had to do a huge amount of work to our media code, which is completely centric towards the kinds of SIP behaviors that we had been doing for most of our uses. So what our mission is to take all the code that we already had in our SIP module for media handling and extract it into our core to make it more abstract, because we are now going to have like WebRTC and or SIP both using sort of the same kind of media interface. And that was really important because we don't want to duplicate anything, because we kind of had, in our Jingle module, we were just using our same RTP stack. But with all the extra complexity involved in WebRTC, it was more than just the RTP stack. We had actually invented a giant layer that's like quickly grew to countless lines of code in our repo very quickly. Like we go in there and measure it. Now I can't remember what it is, but it's horrible. It's like 23,000 lines of code or something. So we had to take this code and we had to add in these other features to make sure that we could be supported. These are all things that have been around for a long time, but no one in the mainstream user base of us, at least, used any of these things before. So to us, we had to implement them all. And what's nice, you see WebRTC is being used by a lot of other people. They're just using it on the outside, like making an app and having a browser on both sides. But with us, we're actually having to implement the media stack too, so that we communicate with it and not break compatibility with all the other things that we've been doing before. And then so we were trying to come up with this stuff, and then the big thing about WebRTC is it's signaling agnostic so that you can use your own. But then we had to decide which kind of signaling we're going to use. So we broke it into pieces, and our first step was to get the media flowing, just to make sure that our engine was even compatible. So, as I was saying, that a lot of these apps are browser-to-browser centric, so you're just talking about writing some JavaScript code and maybe something for, to hand the STP over to the other browser, and then you can talk and be happy and everything. But that wasn't good enough for what we needed. We needed to get a media stream pointed right at our software that we were writing. So we saw that someone implemented SIP over JavaScript, and that's pretty much the closest thing to what we already did. So we used Camilio, which is a popular SIP router, and they actually had some WebSocket to normal SIP translator module. So to start with, we just used that, pointed the browser at it, and used one of these SIP JavaScript stacks and turned it into an ordinary SIP UDP call, but with the WebRTC STP, which would give us something to work with. So our initial testing revealed complete and utter failure. Everything we had was completely wrong for what we needed to be able to do. So it took a lot of functionality upgrades. It was the same kind of familiar trial and error that we had been doing with Jingle, because sometimes it's written down the way it's going to be, but it's not that way yet. So that's always a challenge. Do we want to wait until, we could have just started doing this right now after 1.0 spec is finalized and stuff, but we wanted to have it, in order to stay running with everything, you kind of have to start at the same time. So by choice, when we do that, we're going to be forced to be on the bleeding edge, and even though things might have an eventual behavior pattern, they don't exhibit that necessarily right away. Like the first time we did VP9, the format of the stream wasn't even at all like what it said. So we tried to implement it like it said, and it didn't work, and then we had to comment that out for later, and then just implement what did actually work. Because they were just, it was temporary solutions here and there, in changing the name of APIs and whatnot, depending on if they're finalized. So these are frustrating things, but at least we understood why they were happening. So our initial challenges were, we already have SRTP in Freeswitch, so the first kind of cut of WebRTC was using SDIS, but we knew DTLS was going to be required, so it didn't really satisfy us that we did that, so we had to go and work with that problem. And one of the challenges are that being a WebRTC endpoint, we don't want to slow down all the functionality we already had, because we have people using our software for high-density amounts of traffic, like aggregating SIP calls to ISPs and whatnot. So we have to make sure that all the changes we make aren't going to cause regressions that are going to slow down things for other people. So, and we needed a better means of signaling, because we were kind of having a hard time with the SIP over JavaScript thing. It's kind of like we always chuckle when we hear it, even today. But we need signaling now that we had the audio flowing. But so we also made SIP over WebSockets work with our existing SIP stack, because it seemed like another phase towards things. At least we could support our own connections now with the browser for both the signaling and the media. So we did that because it was another kind of couple weeks worth of work versus anything else, and not having to rely on Camilio all the time. So we got that working, and so we managed to get audio calls up, and this was happy for some people. Freeswitch kind of represents the niche between the future and the past, because a lot of our users are still using kind of the first era of real-time communication things, such as hardware SIP phones and soft phones, and now with mobile kind of repopularizes it. So we managed to get those things working so that you could make audio calls, and almost the majority of our users were thinking about it in the terms of, now I can make a SIP phone built right into my web browser. It's very popular, obviously, and you see that a lot. So they wanted to be able to have my company uses a web browser, but you can click this button to talk to somebody, because on the other end we could call out any protocol. We could call over the PSTN or call in the conference or whatever, so they'd make a SIP-based phone and build whatever random product they fit their needs with that. And we had a lot of uses on that, and so that drove a lot of our development for a while. So with video, we had a bunch of challenges with that. So even though we had it working, it was still pass-through. And the WebRTC, is all about trying to minimize port use. So you've got RTCP being mixed together, and you've got the audio and the video mixed together, and it's all on the same port, which is a little tricky when it comes to this stuff because we're doing pass-through, so almost all the stuff in the packet is kind of useless to us. We got to get this done out of the way, and then we have to pull out the media, and then pass that through. Say the other side of the call was an ordinary SIP phone or something, where you have to present them with like the raw codec stream. And we have to translate back and forth keyframe requests and whatnot. And it just really was kind of frustrating as far as usability went. So we didn't really focus on it, though, because still there wasn't that much work, that many video type of things yet, because this is a couple years ago still. There was already some video services making things, but as far as our arena, we weren't really getting enough attention towards it. So we worked on improving our audio stuff. We created the virtual protocol, which is part of Freeswitch. It's a JavaScript-based signaling library that kind of is tailored to being used with Freeswitch and HTML5 at the same time. So rather than being focused on some media sessions like SIP was, it was more about being able to extend things from Freeswitch into a HTML5 app and make these communication protocols at the same time. So we added support for stereo audio because that was a cool thing you could do now with Chrome. They had they're the first ones to have it, so we figured why not. We actually implemented the ability to have all of our codecs operate in stereo. And then using OpenAL, we were able to make 3D positioning, so you could place imaginary table or put them in various coordinates, so you would hear everybody in a different position. Which kind of worked well. We had weekly conference calls, and when we implemented that, it was a little easier to have conversations because people could talk over each other, and you could actually allow that. Like normally, when all the audio is mixed on top of each other, if two people talk at the same time, it kind of just like makes them both, their brains melt. But we found that with the 3D positioning stuff, you could actually kind of let someone else talk in the background. You could still tell it was two different people, which was a new thing. Because a lot of people can't tell the difference. You kind of have to learn how to talk on conference calls because it's very disorientating for new people that don't use them very often because you're hearing like 5 different people talking and you don't know if it's all the same person or not. And, from us, we've been working so long, we can recognize people's voices really well because we're so used to it. So we can actually tell the difference between different people talking. So after a while, when we got the audio down, we decided to look back at video again. And it was clear, based on some problems we had with trying to make video conferencing work with the way we were doing it, just never going to be enough. So we decided that we're going to make video transcoding. We started out by making the VPA codec kind of a native format inside of Freeswitch, the same library that VP8 uses in VP9. And we implemented video transcoding using our SIP module and our virtual protocol. And we added the video MCU functionality to our conference module, which is one of our oldest modules. We've been using it since we started the project, basically. We work while we're in that conference call and talk all day long over voice over IP calls so that we can collaborate without paying money for phone calls or whatever. And we had done a lot of development, and it helps us define issues. And we also tried to sprinkle as much video concept into the different things that we already had as we could. Music on hold became video on hold and certain things like that. So places where you could play files, you can now play video files instead of just audio files. And we've been doing that for a while now. So I want to get to the current time. Now that the JavaScript API for WebRTC is finalized towards 1.0, we started to use adapter.js so that we could get a head start on that and keep up to date. That allows us to make compatibility with lots of different things because we now can do most of our audio and video things with Chrome, Firefox, Safari, and Edge. Safari right now is through the Temesis plugin, but they also use adapter.js, so we put that in there. We're figuring one day that'll get replaced with native Safari. when WebKit and everything catches up. So now let's see, turn it over to these guys and see if you have any questions for the team. And also, if you see the video call on the TV set there is just a copy of our WebRTC interface, Virtual Communicator, which is an HTML5 app made by community members with feedback from us. And it uses the Virtual protocol to implement and use some of the more advanced capabilities in it to do things like the conference list and tell who's talking stuff, as well as separating it out. So we have Ken who's in there who can demo some of it, and we have these guys who can answer some of your questions.
Go ahead, William.
Okay. One thing to note on this is we're actually acting as an MCU here, whereas this makes it different from other WebRTC implementations. There's one stream from each client to the server and one stream back to the client, and the server is actually muxing and mixing them together. So we can do overlays. So if you see in the top right of each of the videos, we can do basically watermark or overlays. We can add labels so that you can actually, on the server side, you can control somebody's name, email addresses, and things like that. And then Brian can give an example of video muting. So if you want a little bit of video privacy for a second, server side we can control, or client side. So.
And something else Anthony didn't hit on. We've kind of gone completely the other direction. You know, we have audio, video. Some of the things that we've been asked for are things like MSRP and RTT. Those things are coming. We have them in tree. We're testing them. These are some of the things that are mandated by the FCC. MSRP is for SMS to 911 is where it's getting used, and RTT is for deaf callers over IP. So we support those things coming through down the pipeline. In addition, as of just a little bit ago, I finished up testing the iOS 10 TTY client that's built in. There's a software TTY with iOS 10. It works with Freeswitch. You can actually interact with the Lua script and or bridge and interact. Our final goal will be to bridge something like TTY from the PSTN to RTT on the IP network, or vice versa, something MSRP to RTT, or any mixture of these things. This protocol translation is what we've always been good at. So abstracting this out to where all of these things can talk to each other. You can go SMS, SMPP, all of these things will interact, and a lot of these things are required moving forward for the newest E911 stuff.
We added our own text transport to our Virtual protocol too, so you'll be able to bring all that into an HTML5 environment.
So you'd be able to translate from Virtual to RTT. It would just happen.
Are there any questions? I mean, Bernard?
Yeah, so on the accessibility stuff, do you plan to support RTT over the data channel for that kind of, because that's basically the only way to use RTT, I think, in the WebRTC world?
Is there a spec on that right now?
I think I remember one. It still may be an individual submission, but yeah, I think people have been working on it.
We're doing it right now with Virto, which is not RTT. It's a text chat protocol with Freeswitch that then can be translated into RTT server side and sent out. But I will investigate the RTT over the data channel because that is very interesting.
One more.
Hi, on the scalability side, so how many people can be watching the streams and how many streams can be broadcasted at the same time?
So we actually have a couple of different ways that you can do it. If you've got members, we've got a funny story where we killed the amperage in a data center because we loaded up too many video streams in a 9x9 grid, doing all the different transcoding. But we, every week for our weekly call, can stream live to YouTube. So you got your video server doing your video call conference, and then all of the additional scalability is just one stream out to YouTube, and then all the read-only viewers can watch that stream.
But without YouTube, how many people can be watching it?
It depends on your hardware.
There's a lot of variables: canvas size, bit rate, members, participant data coming in. The frame rate is a big one that will dictate a lot of this as well. We've gotten 40 to 50 people. Once you get to that point in a video conference, they're postage stamps, and it's not as useful. And that was on a 24 core with 48 gigs of RAM. I think it was like a 2.1 gigahertz, 24 core. And that's one of the ones we popped the breaker in the data center and took our whole network out.
The one thing But one thing to note is the difference between some WebRTC implementations and using Freeswitch for the video calls is if you put in a 4 or 5 person in a Google Hangouts, you hear a fan here, all the different participants will start turning into little hoverboards. Whereas with the MCU route, you're just moving that cost into a cloud or a server, and your clients are all still very low power usage because they're all using the hardware renderer and decoder.
It's great for mobile.
Yeah.
Yeah, that's the other thing that's the challenge for us, because we have, in one day we might have a conference call and there's somebody on a mobile SIP client using video, which has actually started to catch up with the rest of the world, because for a long time it was SIF and QSIF or something, little tiny resolutions, but now you have 720p on a mobile phone and you have people calling in that way, and then you have someone else is calling in through the PSTN, and then you have like what's in there now all at the same time, and we have to make it all work together. So it's not only limited to WebRTC, it's just one of the interfaces. It's the best because you can have high quality audio and stereo and video that are brought to you from the browser.
Well, we have to wrap up to get ready for our next panel session, but let's everyone thank the Freeswitch crew. Thank you guys.